Ghana Teacher Licensure Exams 2025. So this is general professional knowledge, and in this section we are going to look at the part 2, which is the numeracy. And these questions came in July 2025. Let's begin with the first question. A rectangular floor of dimensions 4 meters by 3 meters is to be tiled fully with 20 centimeters by 20 centimeters square tiles. What is the minimum number of tiles that will be required without any broken ones to tile the entire floor? So we have our rectangular floor. This is our square tile. So the rectangular floor has the dimensions. So it has the length as well as the width. Now with the square tile, because in a square all the sides have equal length, the length was given as 20 centimeters. Also with the floor, the length was given as 4 meters and the width as 3 meters. So even right from the onset, we could see that something is not right. The dimensions of the floor was given in meters, whilst the dimensions of the tile was given in centimeters. So you must always make sure that the units in both cases are the same, simply because at the end of the day we want to find out how many of the square tiles will be needed to tile the entire rectangular floor. So before we can compare, we must make sure that they have the same units. So in doing so, it's either we make sure that both cases have meters as their units, or both cases have centimeters as their units. But I prefer centimeters in both cases. So it means that with the square tile, we already have our unit in centimeters, so there is nothing we are going to do. All that we are going to do here for the rectangular floor is that we are going to change the dimensions from meters to centimeters. Now we know that every 1 meter is equivalent to 100 centimeters. Every 1 meter is equivalent to 100 centimeters. So now with the length, we know that is 4 meters. So if 1 meter is giving us 100 centimeters, then 4 meters will give us 400 centimeters. 3 meters will give us 300 centimeters. So with the length of the rectangular floor, instead of 4 meters, we now have 400 centimeters. And with the width, in place of 3 meters, we now have 300 centimeters. Next, let's calculate the area of the rectangular floor as well as the area of the square tile. So let's begin. Area of the rectangular floor. So because the floor is in the shape of a rectangle, we know that the area of a rectangle is given as length multiplied by the width. Now with the length, we have 400 centimeters. With the width, we have 300 centimeters. So what will be the area of the rectangular floor? 400 centimeters multiplied by 300 centimeters. We have 120,000. 120,000 centimeters squared. So that is the area of the rectangular floor. Now let's also calculate the area of the square tile. area of the square tile. So the area of the square tile, we know that the tile is in the shape of a square, and then the area of a square is given as L squared. And then we know that the length of the square tile is 20. So we have 20 centimeters squared. So what is 20 centimeters squared? 20 centimeters squared, 400. So the area of the square tile is 400 centimeters squared. Now to our main question. We are looking for the number of tiles that will be needed to tile the entire rectangular floor. So in other words, they are asking us that how many 400 centimeters squared are there in 120,000 centimeters squared. So to answer this particular question, we have to divide 120,000 centimeters squared by 400 centimeters squared. Now we know that the centimeters squared will cancel out. So let's see. We have 120,000 divided by 400, 300. So we need 300 tiles. 300 tiles. So we select option B. Question 2. Which of the following nets can be folded to make a square pyramid? What then is a square pyramid? So we know that a square pyramid is a pyramid whose base shape is a square. The one thing about pyramid is that the name of the pyramid is always derived from the shape of its base. So if the base of a particular pyramid is in the shape of a rectangle, then we have a rectangular pyramid. If the base shape is a triangle, we have a triangular pyramid. If the shape or the base shape is a square, then we have a square pyramid. So first of all, let's draw the base shape. Let's draw the base shape. In our case, it is a square. We also know that pyramid is a three-dimensional shape with triangular sides that meet at a common point. So let's choose our common point. So let's say this is our common point. So we are going to join the vertices of the base shape to the common point. So this is how a square pyramid will look like. So you can see that all the sides here are in the shape of a triangle. Then the base shape here is a square. So when we try to unfold this square pyramid, what net are you going to get? Which of these nets will look like the unfolded shape? So obviously the base shape will be at the center. So that will be in the shape of a square. And then you see that from the diagram, we have 4 triangular sides. So this is one, the front, the right, and the back. So 1, 2, 3, 4. So it is clear that It is option A. It is option A that can be folded to make a square pyramid. Thank you. Question 3. The average score of 4 students in a mathematics class test was 6. When the score of the 5th student who took the test later was added, the average score of the class became 7. What was the score of the 5th student? Now, what do you mean by average? So in this context, average is the same as mean. Average is the same as the mean. So, and this is the symbol for average or mean. So let's do a quick revision even before we start solving this particular question. Let's say we have 3 particular students in the class who took the mathematics test. These were the individual scores. The first person had 5, second person had 2, and the third person had 8. Now, if you want to calculate the mean score of these 3 students, what do we do? So the mean score of these 3 students will be the sum of the scores of the individual students. So 5 plus 2 plus 8. Then we divide by the total number of students who took the test. In this case, we have 3 particular students. So you know that 5 plus 2, we have 7, then 7 plus 8, that is 15. Then 15 divided by 3, that gives us 5. So all that I want you to know is to know the formula for calculating the mean or average score of some particular student. In this particular example, we have 3 different students. So to calculate the mean or the average score of these 3 students, so there is a notation for the mean score of 3 students. So the mean score of 3 students, that is the notation or the symbol, is equal to the sum. Sum means addition. So as we did, we added the scores of how many students? 3. There were 3. So the sum of the scores of the 3 students. Then we divided by the total number of students who took the test. So this is the formula we have to take note of. In other questions, you can be asked to find the mean score of 10 students. So this will be the formula. The mean score of 10 students will be equal to the sum of the individual scores of the 10 students divided by 10. So that is the approach that we are going to use. Now back to the main question. We have 2 different scenarios. The first one says that the average score of 4 students in a mathematics class test was 6. The emphasis is on 4 students. So let's create a formula for finding the average score of 4 students. We know that the average score of 4 students is giving us the sum of the individual scores of the 4 students divided by 4. So that is the formula. But we can do some substitution because we were given the average score. So what was the average score of these 4 students? So the average score of 4 students in a mathematics class test was 6. So the average score was given as 6. So in place of average score, let's substitute 6. So we have 6 is equal to the sum of the individual scores of the 4 students divided by 4. Let's calculate for sum of 4. So 6 can be written as 6 on 1. Let's cross multiply. 6 times 4, we have 24. And then 1 times sum of 4, that gives sum of 4. So the sum of 4 is equal to 24. What does this information tell us? Sum of 4. So sum of 4 here is telling us that when we add the individual scores of the 4 students, there is a total score we are going to get. You see from the introductory part, when we added the 3 scores, we had a total of 15. So in this particular case, sum of 3 is 15. Here, sum of 4 is 24, meaning that when we add the individual scores of the 4 students, we are going to get a total score of 24. So that is for the first instance. Now let's also look at the second part of the question, which says that when the score of a 5th student who took the test later was added. So initially there were 4 students who took the test. We had a total score of 24. Now there is another student, that is the 5th student, who now takes the test later. So once a new student has been, or the score of a new student has been added, the total number of students is no more 4, but rather 5. So let's create a formula for calculating the average score of 5 students. So we know that the average score of 5 students is equal to the sum of the individual scores of the 5 students divided by 5. So what was the average score when the 5th student took the test? So the average score moved from 6 to 7. So the average score here is now 7. So this must be equal to sum of 5 divided by 5. So now let's calculate sum of 5. You know that 7 can be written as 7 on 1. We cross multiply. 7 multiplied by 5, we have 35. And then 1 times sum of 5, we have sum of 5. So sum of 5 is giving us 35. What is the meaning of sum of 5? So it means that this time when we add the individual scores of the 5 students, we are going to get a total of 35. When they were 4, the total score was 24. Now that they are 5, the total score is 35. So how then do we get the actual score of the new student? In other words, the actual score of the 5th student. So the difference, when they were 4, 24. So when we added the score of the 5th student, their total score increased to 35. So the score of the 5th student, score of the 5th student will be the difference, that is 35 minus 24. Let's see the result. 35 minus 24, 11. So the right answer is option C. Question 4. What volume of water can completely fill the container in the diagram if 1000 centimeters cube of water is equivalent to 1 liter? So the first thing we do is that let's calculate the volume of the container. So the volume here is telling us the amount of space inside this particular container. So you could see that in the container, they've given us the dimensions. So we have the length giving us 50 centimeters. We have the width giving us 10 centimeters. And then the height giving us 30 centimeters. And we know that the volume of a box is giving us the formula length times the width multiplied by the height. So the length we have 50 centimeters, the width we have 10 centimeters, and the height we have 30 centimeters. So let's see the volume. 50 centimeters multiplied by 10 centimeters multiplied by 30 centimeters. We have 15,000. So we have 15,000 centimeters cube. But then we want the volume in terms of liters, knowing that every 1,000 centimeters cube is equivalent to 1 liter. So this time we have 15,000 centimeters cube. So if 1,000 centimeters cube is giving us 1 liter, then 15,000 centimeters cube. So that is 15,000 centimeters cube divided by 1,000 centimeters cube multiplied by 1 liter. So the centimeters cube can cancel out. Let's see. So we have 15,000 divided by 1,000. We have 15 liters. So this will give us 15 liters. So we select option C. Question 5. What is the area of triangle ABC in the diagram below, given that the base is 40 meters long and the perpendicular height is 75 meters? So the base length is 40 meters and the perpendicular height is 75 meters. We are looking for the area of triangle ABC. We know that the area of a triangle is given by the formula half multiplied by the base multiplied by the perpendicular height. So all that we do is substitution. We know the base as 40 meters and the perpendicular height as 75 meters. So let's see the result on the calculator. So we have half multiplying the base length, which is 40, multiplied by the perpendicular height, which is 75. 1,000, so 1,500 meters squared. So the right answer is option B. Question 6. The dot plot shows the marks of students in the mathematics class test. What is the modal mark of the class test? So in statistics, we have different ways of representing data. And one of the ways of representing data is using the dot plot. Using the dot plot. So let's analyze the dot plot here. So we are told that the dot plot here shows the marks of students in the mathematics class test. So the scores of students in the mathematics class test. So these are the ranges of scores. So we have 0, 1, 2, 3, 4, 5, 6, up to 14. So these are the scores or the marks that we expect students to get in the class test. And then the dot here is telling us the number of students. So you could see that for a score of 0, there is no dot there, meaning that no student had a score of 0. A score of 1, we have only one dot there, meaning that only one student had a score of 1. Only one student had a score of 2. No student had a score of 3. 2 students, a score of 4. No student scored 5. 1 student scored 6. No student scored 7. 3 students scored 8. 1 student scored 9. No student had a score of 10. 2 students scored 11. 1 student scored 12. 1 student scored 13. And then no student had a score of 14. So that is the interpretation of this particular dot plot. But our goal here is to find the modal mark. So what then is the modal mark? So the modal mark, we are looking at the mark in which majority of the students in the class had. So the most frequent score in the test. And from the dot plot, you could see that that is a score of 8 because we have 3 students scoring 8 marks. So the most frequent score, in other words, the most popular score in the class is a score of 8. And that represents the modal mark. So we select C. The next set of questions. So we have a bar graph. And then this bar graph here represents the type of t-shirts a group of teachers ordered for a speech day. So we are to use the graph to answer question 7 and question 8. So remember, bar graph is also another way of representing data. So from the bar graph, you could see that we have 4 different categories of t-shirts ordered by the teachers. So we have small, we have medium, we have large, and then we have extra large. So let's find out the total number of teachers who ordered each category of a t-shirt. So for the small, the small size t-shirt, from the graph, it is in between 8 and 9. Sorry, in between 8 and 10. So in between 8 and 10, it means that there are 9 teachers. Medium, how many teachers? In between 12 and 14. In between 12 and 14. So that is 13 teachers. Large, exactly on 6. So we have 6 teachers. And then for extra large, also 6 teachers. So that is for extra large. But with question 7, we have to find how many teachers place the order. Remember, we were told that each teacher ordered only one t-shirt. So if that's the case, then how many teachers place the order? So the total number of teachers who place the order will be 9 plus 13 plus 6 plus 6. So let's see. 9 plus 13 plus 6 plus 6. 34. So we have 34 teachers. So we select option A. Question 8. How many more medium-sized t-shirts were ordered than large-size t-shirts? So let's find out the number of medium-sized t-shirts ordered and then the number of large-size t-shirts ordered. We have already done this. So for the medium, 13 was ordered, and then for the large, 6 was ordered. So 13 for medium, 13 t-shirts for medium, 6 for large. So it is clear that they ordered more medium-sized t-shirts than large-sized t-shirts. But what is the margin? So that would be the difference. So we have 13 minus 6. 13 minus 6. So that gives 7. 7. So the correct answer is option A. 7 more medium-sized t-shirts were ordered than large-size t-shirts. Question 9. A head teacher orders exercise books from a stationery store. The books are supplied in packs of 5 and 6. So packs of 5 and 6. What is the minimum number of packs of the exercise books the head teacher will receive if each of the pack is supplied? So there is a key word here, minimum. So the minimum number of packs, minimum. So that is the least common multiple. So all that we need to do is to find the least common multiple of 5 and then 6. So first of all, let's start with the multiples of 5. So multiples of 5, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. In that order, it goes to infinity. Then with multiples of 6, we have 6, 12, 18, 24, 30, 36, 42. It also goes to infinity. So let's find the common multiple. Common multiples. So the common multiples, we are looking at numbers that can be found in the multiples of 5 as well as the multiples of 6. So could see that there is 30. There is 30. If we keep on moving to infinity, I think we can still get 60 and 90. They are all common multiples. All these numbers can be found in 6 as well as 5. But what are we looking for? What are we looking for? We are looking for the least common multiple. So the least common multiple is talking about the smallest number that can be found in multiples of 5 as well as multiples of 6. And it is obvious that that is 30. So we select option B. Question 10. The standard deviation of a set of scores of 90 students in a mathematics test is 15. If the score of each student is decreased by 9, then what will be the standard deviation of the new observations? So there's a question on the standard deviation. You know that standard deviation enables us to measure how much the individual scores is spreading around the mean, or how much the individual scores moves away from the mean score. So let's quickly go through some activity in order to answer question 10. Let's say we have 3 students who took part in the mathematics test, and these are their individual scores. So let's say the first person had 4, second person had 7, and the third person had a score of 10. How do we calculate the standard deviation? So to calculate the standard deviation, the first thing we do is that we need to calculate for their mean score. So the mean score of these 3 students will be the sum of their individual scores divided by the total number of students, in this case 3. So we have the mean score of the 3 students, 4 plus 7, that is 11, 11 plus 10, 21. So 21 divided by 3, that gives us 7. So the mean score of these 3 scores is 7. Now, how do we calculate the standard deviation? So to calculate the standard deviation, the first thing is that we need to calculate for the deviations of the individual scores. So the deviations here is telling us how much the individual scores is moving away from the average or the mean. So let's calculate the deviation for the first score. So the deviation of the first score here is 4. So that is 4 minus the mean, 7. This gives us minus 3. Deviation of the second score. So that is 7 minus the mean score, 7. This gives 0. Then the third score, 10 minus 7. This also gives 3. Next is the square of the deviations. The square of the deviations. So the square of the deviation, the first score here is minus 3. So minus 3 all squared. This gives us positive 9. Then the next one, 0. So 0 squared, that is 0. And then the third deviation, positive 3. So positive 3 all squared, that gives 9. So these are the squares of the deviations. Next, we are going to find, or we are going to sum up the square of the deviations and divide by 3 because we have 3 different students. So the first square deviation, we have 9 plus the second square deviation, 0, plus the third square deviation, 9. The whole of this divided by 3. 9 plus 0 plus 9, we have 18 divided by 3. And then 18 divided by 3, that is 6. Finally, the standard deviation will be the square root of this answer, which is 6. So what is square root of 6? Square root of 6. So 2 decimal places. 2 decimal places, we have, that would be 2.45. 2.45. So let's take note of this particular answer. So for the first case, we had the standard deviation as 2.45. We are also going to look at a second instance. So with the second instance, this is what we are going to do. We are going to decrease the individual scores by a certain constant. We are going to decrease In other words, you're going to reduce their individual scores by a constant. So remember, at first, this was their individual scores. Their individual scores was 4, 7, and then 10. Now we are going to decrease each of the scores by, okay, let's choose 2. We're going to decrease by 2. Once we decrease by 2, what do we have? When you decrease 4 by 2, we are left with 2. Decrease goes with subtraction. So 4 minus 2, that is 2. When you decrease 7 by 2, we have 5. When you decrease 10 by 2, we have 8. So let's calculate the standard deviation of the new scores and see. So remember, the first thing we do is that we need to find their average score. In other words, their mean score. So that is the sum of their individual scores. Because we still have 3 students, we divide by 3. So 2 plus 5, that is 7, and then 7 plus 8, we have 15. So 15 on 3. And then 15 divided by 3, that gives 5. The next thing is that let's find the deviations. So the deviation of their individual scores. So deviation. So the first one, the deviation here will be 2 minus the mean. So that is 5. The second one, 5 minus 5. On the third score, 8. So 8 minus 5. So let's see. 2 minus 5, we have minus 3. 5 minus 5, we have 0. And then 8 minus 5, we have 3. Next, we are going to find the square of the deviations. Square of the deviations. So the first one, minus 3 all squared. Minus 3 all squared, that is positive 9. 0 all squared, we have 0. Positive 3 all squared, we have 9. Next, let's find the sum of the deviations of the squares. So the first one, we have 9 plus 0 plus 9. Remember, we are looking at 3 students, so we divide by 3. 9 plus 0 plus 9, we have 18 divided by 3. And then 18 divided by 3, that is 6. Now we want the standard deviation. So the standard deviation will be the square root of this result, which is 6. And we know that square root of 6 to 2 decimal places, that is 2.45. So the second instance, we also had 2.45. So can we draw the conclusion? Initially, when we used our case study, we had the standard deviation to be 2.45. Now, when we decreased their individual scores by 2, we are still getting the same standard deviation, which is 2.45. So if at the beginning, the standard deviation of a set of scores of 90 students was 15, and now the score of each student has been decreased by 9, what will be the standard deviation? So the standard deviation will never change. The standard deviation will still be 15. So that is one characteristic of the standard deviation. Whether we add a constant number across board, or we subtract a constant number across board, the standard deviation still remains the same. Question 11. If the area of a rectangular field is 2000 square meters and its width is 40 meters, what is the perimeter of the rectangular field? So we have our rectangular playing field. So once it is a rectangle, it will surely have two dimensions. So the longest side is the length and the shortest side is the width. We know that the width measures 40 meters, but we don't know the actual measure of the length. But again, we know that the area of this playing field measures 2000 square meters. So we have to calculate for the perimeter. So we know that before we can calculate for the perimeter, we need the actual measure of the length. Once we know the area and the width, we should be able to calculate for the length. We know that the area of a rectangular playing field is given by the formula length multiplied by the width. Now the area is giving us 2000 square meters. We don't know the length, but we know the width as 40. So we have 2000 being equal to L multiplied by 40, that is 40 L. Once we are looking for L, we divide both sides by 40. So 40 will cancel out. We have L on the right. So 2000 divided by 40. We have 50. So the actual measure of the length is 50 meters. Once we know the length of the playing field, we should be able to calculate for its perimeter. We know that the perimeter of a rectangular playing field is given by the formula 2L plus 2W. So twice the length. The length is 50 meters plus twice the width, 40 meters. So twice of 50, that is 100. Twice of 40, we have 80. And then 100 plus 80, that gives 180 meters. So that is the perimeter of the field. So we select option A. So we have a preamble. That is, the following are the balance in Ghana cedis obtained from 9 teachers' mobile money accounts. The negative balance are in brackets. Take note, the negative balances are in brackets. So let's list the balance of the 9 teachers. Now the first teacher, because the balance is in bracket, it represents debt, negative 100 cedis, so negative 50 cedis. The third person owes 30 cedis, negative. Fourth person owes 20 cedis, negative. So the next person does not owe, the next person does not owe, the next person has 10 cedis to his credit, the next 20 cedis, and then the last person has 90 cedis in their respective mobile money accounts. So question 12, how many teachers do not owe in their mobile money account? How many teachers do not owe? So let's see. So this teacher does not owe, this teacher does not owe, does not owe, That's not O. That's not O. So we have 1, 2, 3, 4, 5. We have 5 teachers who do not owe in their mobile money account. We select option A. Question 13. Which of the following statements is true about the balances in the teacher's mobile money account? So let's evaluate each of the 4 options and select the right one. A. Teacher with the highest credit balance had 100 Ghana cedis. Let's see whether it is true. So you could see that negative represents debt and then positive represents credit. So all these teachers owe in their mobile money account. So these are the creditors, and the teacher with the highest credit balance has 90 Ghana cedis. So the first statement is not true. B. The 9 teachers altogether owed 80 Ghana cedis. So let's see the total amount of money owed by the 9 teachers. So the first teacher owes 100 cedis. The second teacher owes 50 cedis. The third teacher owes 30 cedis. The fourth 20 cedis. So the fifth and the sixth 0. They neither owe nor have any credit in their account. The next teacher has a credit of 10 Ghana cedis. The next has 20 cedis. And then the last teacher has 90 cedis. So let's see their total balance. So they still owe. So 9 teachers altogether owe 80 Ghana cedis. So I think option B is true. Let's also verify option C and C. So with option C, 9 teachers altogether owe 150 cedis. So this is also not right because we have already verified and we saw that the 9 teachers altogether owed 80 cedis. Now D, the difference between the highest and the least balance is 10 Ghana cedis. So what is the highest balance? The highest balance is 90 cedis. And the least balance is 100 cedis. But this one, the teacher owes in the account. So let's see the difference. So the difference, we have 90 plus negative 100. So that is the difference. There's rather 10 cedis, which is owed. So the difference will still be a debt of 10 Ghana cedis. And it makes sense. This teacher owes 100 cedis. This teacher has 90 cedis. So they are different. So the difference is still a debt of 10 Ghana cedis. So this particular statement is also not true. So with this, the right answer is option B. Question number 14. What is the name given to the difference between the largest and the smallest values in a data set? We know that this is range. So range is the difference between the largest and the smallest values in a data set. So the right answer is option A. Question 15. Which of the following algebraic expressions is equivalent to the sum of 5 and a number x? Now we know that in algebra, the word sum denotes addition. So sum denotes addition. And since we are 5 and x. Again in algebra, 5 plus x is 5 plus x. So from the alternative, let's see whether we can find 5 plus x. In the alternative, there is nothing like 5 plus x. But one thing is for sure, that is addition is commutative. When we say addition is commutative, then it means that, for example, we know that 2 plus 3 is the same as 3 plus 2. So irrespective of how we order the terms, so even if we change the terms when it comes to addition, it does not affect the final result. 2 plus 3, that is 5, and then 3 plus 2, that is 5. So it is clear that 5 plus x is also the same as x plus 5. So with this, we select option D. Question 16. Which of the following is a set of whole numbers less than 5? We know that whole numbers start from 0 all the way to infinity. So it is endless. It goes on and on and on to infinity. But then we are looking at whole numbers less than 5. So we are looking at whole numbers less than 5. So that would be 0, 1, 2, 3, and 4. So with this, we select option D. Question 17. Kofi is 2 years older than Amma. So let's say we have Amma and this is Kofi. So it is clear that Kofi is older than Amma, but Kofi is 2 years older than Amma. So if Kofi is 11 years old now, so now Kofi is 11 years. How old will Amma be? So we have to find Amma's age now, knowing that Kofi is 2 years older than Amma. So if Kofi is 2 years older than Amma and Kofi's present age is 11 years, then to get Amma's age, we have to subtract 2 from 11. So that gives us 9 years. So comparing 9 and 11, we see that 11 is 2 more than 9. In other words, Kofi is 2 years older than Amma. The right answer is option D. Question 18. Which of the following fractions is between 2/3 and 3/4? 2 out of 3 and 3 out of 4. So to solve some of these questions, I will advise that you convert them into decimal fractions. So let's begin. Let's begin with 2 on 3 and see. So on the calculator, we enter 2 on 3. We press the equal sign. This gives 0.666666. That is a recurring decimal. So 0.6666, it goes to infinity. Next, 3 on 4. let's see. 3 on 4, the decimal fraction. This is a terminating decimal. It ends 0.75. So let's begin with option A. Option A, we have 4 on 5. So 4 on 5, let's see the decimal fraction for 4 on 5. 4 on 5, that gives 0.8. B, 1 on 2, that is half. Decimal fraction. So 1 on 2, that is 0.5. 0.5. C, we have 1 on 4. Let's see the decimal. 1 on 4. We have 0.25. Then last one, D. We have 5 on 7. Let's see the decimal. 5 on 7. So 0.7142. Okay, so 0.7142. So this is goes to infinity. Now let's compare. Let's focus on the 2 decimal places. So 0.8, let's add 0, making 2 decimal places. 0.5, let's add 0, 2 decimal places. So we are looking for a fraction that is between 0.666 and then 0.75. Now the first one, 0.80, it is outside the given range, so this cannot be the answer. 0.50, that will be behind 0.66, so this is also not part. 0.25, this one is even much lesser, outside. And then 0.71, 0.71, that can be located between these two fractions. But in the actual question, we were not given 0.71, we were given 5 on 7. So we select option D. Question 19. What is the largest number that can exactly divide 36 and 84 without any remainder? So we have two numbers, 36 and 84. So which of these 4 numbers can divide 36 and 84 without any remainder? And it is not just any number. We are looking at the largest number among these alternatives that can divide 36 and 84 exactly without any remainder. So let's do an analysis. Let's start with option A. So with option A, we have 36. So let's divide 36 by 36. So the result will be 1. Let's divide 84 by 36 and see. So 84 divided by 36. So we are getting a fraction, 2.33. So although it can divide 84, but there is a remainder. So we have 2.333333, 2.3333. So that cannot be the answer. Yes, 36 can divide 36 exactly without any remainder. But when you divide 84 by 36, there is a remainder. So that cannot be the answer. Let's also verify option B. So option B, we have 18. We are going to divide 36 by 18 and also 84 by 18. Let's verify the results. 36 divided by 18 2. So there is no remainder. Let's see the second one. 84 divided by 18. Another common fraction. So 4.6666. 4.6666. There is a remainder. So 18 cannot be accepted. Next, let's also verify with 12. 36 divided by 12 and then 84 divided by 12. 36 divided by 12, that is 3. There is no remainder. But what of 84 divided by 12? 84 divided by 12. So 7. So this is exact. This gives 7. Okay, so let's see the last one, option D, 6. Option D, we are going by 6. So 36 divided by 6, that is 6. And then 84 divided by 6. Let's see. 84 divided by 6. That is also exact, 14. So for now, 12 and then 6. These two numbers can divide 36 and 84 exactly without any remainder. But which of them is the largest number that can divide these two numbers? So obviously that is 12. So in this case, we select 12. Then we eliminate 6. So the right answer is option C. But remember, the largest number that can exactly divide 36 and 84 without any remainder is the highest common factor of 36 and 84. So you could have also calculated the highest common factor for 36 and 84, and that will also give you 12. You can also try that on your own. Question 20. What is the decimal fraction for the point marked D on the number line? So we are looking at the decimal fraction for the point that has been marked D. So to do this, let's find out what each calibration stands for in terms of decimal fraction. So here we have 0, 0.5, 1, on and on up to 2.0. So from 0 to 0.5, what does each point scale in between 0 and 0.5 stands for? So from 0, here will be 0.1, here will be 0.2, 0.3, 0.4, and then 0.5. We can still continue. 0.6, 0.7, 0.8, 0.9, 1.0. So the next one we have 1.1, 1.2, 1.3, and here is 1.4. So you can see that point D is in between 1, it is halfway between 1.3 and 1.4. 1.1, 1.2, 1.3. So in between 1.3 and 1.4, what decimal fraction should be there? So we can simply find the average. So 1.3 plus 1.4 divided by 2. That will give you the decimal fraction for the point marked D in between 1.3 and 1.4, or halfway between 1.3 and 1.4. So let's see. We have a common fraction. The numerator we have 1.3 plus 1.4, and the denominator we have 2. So 27 on 20, but we are looking for decimal fraction. So let's press the SD. So we have 1.35. 1.35. So we select option C. Question 21. An amount of 500,000 cedis was shared among AC, Yara, and Kafui. So the total amount shared was 500,000 Ghana cedis. Now we are told that AC received 100,000 Ghana cedis. So AC's share of the total money was 100,000. Yara received a fourth of the remainder. So we know that the total amount of money to be shared is 5,000 Ghana cedis. Now AC has already received 100,000 cedis. So what will be the remainder? So the remainder will be 400,000 cedis. And with this remainder, that is with the 400,000 cedis, Yara received a fourth. A fourth is a common fraction written as 1 out of 4. So he received 1/4 of 400,000. So what is 1/4 of 400,000? 1 out of 4 multiplied by 400,000. So that is 100,000. 100,000. So Yara also received 100,000 cedis, while the rest went to Kafui. So how much will be left with Kafui? The total amount of money was 5,000. AC had 10,000. Sorry, AC had, the total amount of money was 500,000. AC had 100,000. Yara had 100,000. So what will be the remainder? So the remainder will be 300,000 cedis. But then we are to find the ratio in which the money was shared. We know that ratio compares, or ratio enables us to compare things. In this case, we are to compare their individual share. So to do that, we must reduce the amount received by each of them to the lowest form. So we can cancel out the thousands, we can cancel out the thousand, we can cancel out the thousand. We can still cancel out the hundreds, can cancel out the hundreds, we can cancel out the hundreds. So we are left with 1, 1, and then 3. Because we are looking at ratio, we are going to compare. AC is to Yara is to Kafui. And that gives 1 is to 1 is to 3. 1 is to 1 is to 3. We select option D. Question 22. So the table below shows the weight in kilograms of 4 babies. So these are the names of the babies. Peter. So his weight is 3.269 kilograms. Clara with a weight of 3.314 kg. Rita 3.281, and then Sam 3.238 kilograms. So which of the following statements about the babies is true? The first one, Sam is heavier than Rita. Let's see. Let's compare their weights. Sam and Rita. So Sam 3.238, Rita 3.281. So it is Rita who is heavier than Sam. Rita is rather heavier than Sam. Sam is never heavier than Rita. So the first statement is not true. B. Sam is heavier than Clara. Let's compare their weights. Sam 3.238, Clara 3.314. So Clara is heavier than Sam. This statement is also false, that Sam is heavier than Clara. It's not true. C. Rita is heavier than Peter. Rita 3.281, Peter 3.269. Yes, Rita is heavier than Peter. This is true. And then lastly, Peter is heavier than Clara. Peter 3.269, Clara 3.314. This is also false. Peter is not heavier than Clara. This is also false. So the only true statement here is option C. Question 23. What are the two missing numbers represented by the boxes in the pattern below? So we have some pattern of numbers. In this pattern of numbers, we have two missing numbers, and that is what we are looking for. So first of all, we need to study the pattern and see how the numbers are being generated. So in the pattern, are the numbers increasing or decreasing? You could see that the numbers are increasing. So we have 1, 3, 6, 10. We have the missing number 28 and 36. You see that the numbers are increasing. So what is really causing the increase? So let's see. From 1 to 3. Let's see whether there is some difference in them. So from 1 to 3, we could see that there is an addition of 2. From 3 to 6, there is an addition of 3. From 6 to 10, there is an addition of 4. So see the pattern. From 1 to 3, they added 2. From 3 to 6, they added 3. From 6 to 10, they added 4. So obviously from 10 to the missing number, there should be an addition of 5. And we know that 10 plus 5, that is 15. Also from 15 to the next missing number, guess what? That will be plus 6. And 15 plus 6, that gives 21. So let's keep on checking and see whether we can get the exact numbers that has been represented here. So as if Okay, so let's see. In the absence of 28 and 36, let's see, using the same rule, whether we can get the same numbers. Let's see. So from 21 to 28, that should be plus 7. And then from 28 to 36, an addition of 8. So 21 plus 7, that gives 28. And then 28 plus 8, that also gives 36. So the two missing numbers in the pattern is 15 and 21. So we select option B. Question 24. Miracle bought 6 pence at shop A for 21 Ghana cedis, and Amina bought 4 pence of the same type at shop B for 16 Ghana cedis. So we have shop A and shop B. Now shop A, 6 pence comes at a cost of 21 cedis, and with shop B, 4 pence comes at a cost of 16 Ghana cedis. So how much more did Amina pay for a unit cost of the pen than Miracle? So for the unit cost, we are looking at the cost of 1 pen in each of the shops. So they are saying that we have to find how much Amina paid more than Miracle in terms of the cost of a pen. So first of all, let's calculate the cost of a pen in each of the shops. So in shop A, cost of a pen. Cost of a pen also means the cost of 1 pen. So the cost of 1 pen in shop A, the total cost here was 21 cedis, and then 6 pence was bought. So the cost of 1 pen will be 21 cedis divided by 6. Let's see the results. 21 cedis divided by 6. So let's change it to decimals. So that is 3 cedis, 50 pesos. 3 cedis, 50 pesos. So that is the cost of 1 pen in shop A. Let's also calculate the cost of 1 pen in shop B. So 4 pens coming at a cost of 16 cedis. So the cost of 1 pen will be 16 cedis divided by 4. Let's also check the result and see. Sixteen cedis divided by 4. So that is exact. We have 4 Ghana cedis. 4 Ghana cedis. So we can now compare the cost of a pen in shop A is 3 cedis 50 pesos, and the cost of a pen in shop B is 4 Ghana cedis. Remember, this is how much each of them bought the pen. Shop A was shopped by Miracle, and then shop B was shopped by Amina. So it is clear that Amina paid more in terms of the cost of a pen than Miracle. But let's look at how much more she paid. That is the difference. 4 Ghana cedis minus 3 cedis 50 pesos. That is 50 pesos. And from the alternatives, option D is 50 pesos. Question 25. Fatima planted 2/3 of her farmland with cassava, 1/6 with maize, 1/12 with okra. If the rest of the farmland was left to fallow, then what fraction of the land was left to fallow? So this is a practical problem involving application of common fractions. So first of all, let's represent our farmland. So this is our farmland. Now in this farmland, we are told that 2/3 of it was used to cultivate cassava. So let's demarcate 2/3. Please, it is not drawn to scale. It's not drawn to scale. So let's say this particular portion, the whole of this portion was used to cultivate cassava. So cassava, 2/3. Then again, 1/6 with maize. So let's also demarcate 1/6 for maize. So let's say this is 1/6. So that is for maize. This portion maize, 1/6. Again, 1/12 with okra. So 1/12 was used to cultivate okra. Okay. So this is for okra. This portion, okra. 1/12. And the remaining portion was left to fallow. That is, it was left to rest for some time. That is a common practice in agriculture. After a piece of land has been used for some specified period of time and it has lost all of its nutrients, it is left to rest in order to regain some nutrients. So we are looking for this particular fraction. Remember, fraction represent part of a whole. Part of a whole. Fraction represents part of a whole. And one thing you should know is that when it comes to common fraction, in terms of number, the whole is taken as 1. Take note. The whole is taken as 1. That is in terms of number. So the whole is taken as 1. So the total farmland in terms of number is 1. So once we know the total number or the whole is represented as 1, then we should be able to calculate the fraction of land that was left to follow. We just subtract the used fractions from the whole. So 2/3 for cassava minus 1 seed for maize minus 1/12 for okra. So the remaining, that is the balance, will be the fraction that was left to follow. The whole is taken as 1. 2/3 was used to calculate to cultivate cassava, so we subtract that from the whole. 1 seed for maize, we subtract that from the whole. 1/12 for okra, we subtract that from the whole. What will be left is the fraction that was left to follow. So let's find out from the calculator. 1 for the whole minus 2/3 minus 1 seed minus 1/12. So we still have 1 out of 12. 1 out of 12. So we select option D. 1 out of 12. Question 26. The fruit vendor purchased 900 oranges for 180 cedis. So the cost price for 900 oranges was 180 cedis. She noticed that 75 of the oranges were rotten and threw them away. And then the rest of the oranges were sold at 5 for 2 Ghana cedis. So if 75 of the 900 oranges were rotten, let's calculate the remaining number of oranges. So initially there were 900 oranges. And out of the 900 oranges, 75 of them got rotten. So what will be the balance? So 900 minus 75, 825. So 825 remaining oranges. Now with the 825 oranges, that is how she sold them. She sold them in groups of 5. So 5 oranges. 1, 2, 3, 4, 5. So the cost will be 2 cedis. Then again, groups of 5. 1, 2, 3, 4, 5. The cost 2 cedis in that order. That was how she sold the oranges. So first of all, let's find out how many groups of 5 are there in 825 oranges. That is how many fives can be obtained from 825. So to calculate this, we have 825 divided by 5. 825 divided by 5. 165. So 165. So there are 165 groups of 5 in 825. And we know that each group of 5 was sold at a cost of 2 Ghana cedis. So what then will be the selling price of the 825 oranges? So the selling price of the 825 oranges will be these 2 Ghana cedis multiplied by 165, since there are 165 groups of 5 in 825. So the selling price was 2 cedis multiplied by 165. So let's see, 2 cedis multiplied by 165. 330 cedis. 330 cedis. So that is the selling price. So the selling price of the remaining oranges, is 330 cedis, and then the cost price was 180 cedis. So can we calculate for the profit? We know that the profit is the difference between the selling price and the cost price. So 330 minus 180. 330 minus 180. 150. 150. So the profit she made was 150 Ghana cedis. So that is option C. Question 27. Akosua Salon charges 5 Ghana cedis per short hair braided and 8 Ghana cedis per long hair braided. So let's see, 2 categories of hairs. We have the short So every one short hair, the cost is 5 cedis. And also with the long hair, every one long hair, the cost is 8 Ghana cedis. So let's take note of these two informations. The cost of braiding a short hair is 5 Ghana cedis, and the cost of braiding a long hair is 8 Ghana cedis. Now, after breeding a customer's hair, the total amount Akosua received was 130 cedis. But then we don't know the actual number of short hair that was breeded. But then we are told that the number of short hair breeded was given as X. And the number of long hair breeded is given as Y. So we have to look for an equation that represents the total transaction of work done. So now, let's assume we decide to use actual money for the cost of long hair. So let's say in the shop, the cost of short hair was, okay, sorry, we are using the whole of this, but this time we are just representing the number of short hairs. So let's say this customer braided 20 short hairs. So the short hairs we have 20, and then the long hairs we have, let's say 15. Then how do we calculate the total cost? So to calculate the total cost, first of all, we need to calculate the cost of short hairs and then the cost of long hairs. So if the cost of a short hair is 5 Ghana cedis and this particular customer has braided 20 of the short hairs, then the total cost of short hair will be the number of short hairs braided, which is 20, multiplied by the cost of a short hair, which is 5 Ghana cedis, and this will give 100 cedis. Again, if the cost of a long hair is 8 Ghana cedis and this customer has braided 15 of the long hairs, then the total cost of braiding the long hairs will be the number of long hairs, which is 15, multiplied by the cost of a single long hair. So 15 multiplied by 8. So we have 120 cedis. Then we can sum up the total cost of short hairs and then the total cost of long hairs. So that is 100 plus 120, and this gives 220 cedis. So that is for an assumption. But since we don't know the exact number of short hairs braided, and then we want to find out the total cost, of short hair. Per the analysis that we did, we just have to multiply the number of short hairs braided by the cost of a short hair. So we have X multiplied by 5 cedis, and in algebra, X multiplied by 5 gives 5X. So this expression will enable us to calculate for the cost of the X number of short hairs braided by the customer. Next, let's also calculate for the total cost of long hairs. So in this case, we know that Y number of long hairs was braided. So to calculate the total cost, we just multiply the number of long hairs braided by the cost of a single long hair, which is 8 cedis. In algebra, Y multiplied by 8, we have 8Y. We are almost done. Now, We know the total cost of braiding the short hair for the customer, that is 5x. And then we know the total cost of long hair as 8y. So how much will it cost the customer for the short hair as well as the long hair? So we need to add the two, 5x plus 8y. But at the end, what was the total amount of money received by Akosua? She received 130 Ghana cedis. So this is the equation. 5x plus 8y should equal to 130 Ghana cedis. So we select option B. Okay, question 28. Polytank A contains 5,000 liters of water and polytank B contains 2,000 liters of water. So which of the following statement is true about the volume of water in the two polytanks? So we have two different polytanks. So polytank A and polytank B. So for polytank A, this is the volume of water in polytank A. We have 5,000 liters. And then for polytank B, we have 2,000 liters. So it is clear that polytank A contains more water than polytank B. In other words, the volume of polytank A is bigger than that of polytank B. But how much? How much is the volume of polytank A greater than the volume of water in polytank B? So we have to compare. So to compare this, we just divide the volume of polytank A, which is 5,000 liters, by the volume of polytank B, giving us 2,000 liters. So the liters will cancel out. So let's see. 5,000 liters divided by 2,000 liters. So let's change it to common fraction, decimal fraction and see. So decimal fraction, we have 2.5. So 2.5. And we know that 2.5 can also be written as 2.5. 2.5 or 2.5. So it means that the volume of polytank A is 2.5 times the volume of water in polytank B. The volume of water in polytank A is 2.5 times the volume of water in polytank B. So for option A, polytank A contains 2.5 times as much water as polytank B. Yes, this statement is true. Polytank A contains twice as much water as polytank B. This is false. C. Polytank A contains 1.5 times as much water as polytank B. This is also false. And then option D, polytank A contains half as much water as polytank B. This is also false. So the only right answer is option A. Question 29. Printing paper comes in large A0 sizes. The map in the table below shows the number of regions that is formed by folding an A0 sheet into halves several times. So everything has been summarized in this table. So let's focus on the table to answer question 29. So we have a large A0 sheet, that is the plain sheet that we use for printing, the large size. Now, when the sheet has not been folded, we have one plain region. This is very obvious. When the paper has not been folded, we have one plain region. When it is folded once, we have two regions. When it is folded twice, we have four regions. When it is folded three times, we have 8 regions, in that order. Now, if the pattern continues, then how many regions will be formed by the seed fold? We want the number of regions that can be formed by the seed fold. So let's take a closer look at the pattern. You can see that as the number of folds are increasing, the number of regions are also increasing. But what is actually causing the increase? You could see that the number of regions are increasing in multiples of 2. They are increasing in multiples of 2. So that is times 2. And from this to the next one, multiples of 2 times 2. From 4 to 8, we have times 2. Let's see. 1 times 2, we have 2. 2 times 2, we have 4. 4 times 2, we have 8. So the next one, we have 8 times 2. We know that 8 times 2, that is 16. So here will be 16. Then the next one, multiples of 2. So you multiply by 2. So again, times 2. And then 16 times 2, we have 32. And then finally, to the seed fold, to increase by a multiple of 2. So times 2. And we know that 32 times 2, we have 64. So 64 will be here. 64. So once we get to the C. Question 30. A rectangular picture frame has a length of 10 centimeters and a width of 8 centimeters. If 2 centimeters needs to be trimmed off each side to create a smaller frame, what will be the new perimeter of the smaller frame? So let's represent the original picture frame. So this is the original picture frame. We were given the dimensions. Now the length was given us 10 centimeters and the width was given us 8 centimeters. Now we want to trim off 2 centimeters from each side of the original picture frame. So how do we do that? So it is going to be done in this way. Two centimeters from each side. 2 centimeters from each side. So remember, the original picture frame was in the shape of a rectangle. So the trimmed picture frame must also be in the shape of a rectangle. But here the difference is that the distance between the original one and the trim one will always be 2 centimeters. So the distance here will always be 2 centimeters here. So from the original one to the trimmed one, 2 centimeters. The distance here, 2 centimeters. The distance from here to here, 2 centimeters. From here to here, also 2 centimeters. So now let's find out the dimensions of the new frame. The dimensions of the new frame. So let's see the length. What will be the length of the new frame or the trimmed frame? So the full length here was 10 centimeters and 2 centimeters has been cut off. So 2 centimeters minus, and also with this side, 2 centimeters has been cut off. The full length here was 10 centimeters, and this is the trimmed frame. This is the trim frame. So you could see that 2 centimeters off, 2 centimeters off. So in all, 4 centimeters has been taken away from the original length, which was given as 10 centimeters. So the remaining length will be 6 centimeters. That is for the length. Let's also look at the width. The original picture frame had a width of 8 centimeters. And again, we could see that 2 centimeters has been taken off. And this side too, 2 centimeters has been taken off. So with the width, 2 centimeters on the top, 2 centimeters from the down, also making 4 centimeters. So with the width, 4 centimeters has been taken away from the original length, which was 8 centimeters. So 8 centimeters minus 4 centimeters, we are also left with 4 centimeters. So this is the length of the trimmed picture frame. Once we know the length of the or the dimensions of the trimmed picture frame, you should be able to calculate for the perimeter. We know that the perimeter of a rectangle is given as 2L plus 2W. So let's do the substitution. 2 multiplying the new length, which is 6, plus 2 multiplying the new width, which is 4. So 2 times 6, we have 12. And then 2 times 4, we have 8. Then 12 plus 8, that is 20 centimeters. So the perimeter of the smaller frame will measure 20 centimeters. Thank you.